Hello, welcome back. Today we're going to go over an exercise where we're going to evaluate a definite integral which corresponds to the area of a region bounded by four functions. First of all, we're going to construct an area surrounded by these curves, and eventually we're going to write the area in terms of a definite integral. For that purpose, why don't we try to graph y equals 4 plus cubic root of x equals 0, which is essentially y-axis, right? This is y-axis. And we have a vertical line x equals 8. And we have y equals 0, that is as well x-axis. So in other words, the region is bounded by this curve, y equals 4 plus cubic root of x, the vertical line x equals 8, x-axis and y-axis. All right, why don't you go ahead and use your TI-84 to graph those four functions in the same graph and see what the region looks like. So here is what I have. So here is the blue curve. Blue curve corresponds to f. And then I have the vertical line here, x equals 8. I have the x-axis and I have the y-axis. All right, so the region that the question is talking about is this orange region that is in fact the area in between the blue curve and the x-axis for the x's stuck in between 0 and 8. But we know that this area corresponds to the integral of this function 4 plus cubic root of x dx. And x's within that region are stuck in between 0 and 8. I'm going to go ahead and put the lower limit to be 0 and the upper limit to be 8. If we go ahead and find the value of this definite integral, that value is in fact the area between the curve and the x-axis, which is the area of the orange region. So let's go ahead and find the value of the definite integral. So we need to find the antiderivative of 4 and antiderivative of cubic root of x. But we know that antiderivative of 4 is just 4x. All right, why don't we go ahead and write this term in the form of an exponential term. So that is x to the power of 1/3. And we know that the antiderivative of that would be x to the power of 1/3 plus 1 divided by 1/3 plus 1. And we do not add any integrating constant. So as you see, if we simplify this, so you have x to the power of 4/3, and 4/3 also pop in the bottom, but we flip it over. So we have 3/4 x to the 4/3. Okay? So once we have the antiderivative, what we're going to do here is that we're going to call this to be capital F of x. Right, the value of the definite integral here is the antiderivative of f with the bar notation from the lower limit to upper limit, which essentially means that this antiderivative is going to be evaluated at 8. So let me just write it down. 4 times 8 plus 3/4, 8 to the power of 4/3. This is f of 8. And then we subtract what? F of 0. But if you plug in 0 here, so this becomes 0, this becomes 0, this is all 0. Okay? So the value of the definite integral is 32 plus 3/4 of, I think, 8 to the 4. The cubic root of 8 to the 4 is 16. So this adds up to 32 plus 12, which is 44. So 44 is the area between the blue curve and the x-axis. And here what we did is we used a fundamental theory of calculus so that once we have the antiderivative, capital F, so we evaluated it at the upper limit and subtracted f evaluated at the lower limit, and then we got 44, which is essentially the area of the orange region. All right, this is the end of the video. Thanks for watching. I'll see you in another video. Bye.